Good morning, Year 3, and welcome to day 3 of our focus on fractions. First of all, I'll give you the answers to yesterday's problems. I did say for this one you were to draw lines. I've just grouped them all together to make it more obvious, but hopefully you'll have matched these up. Your answers will be varied on this because you had to choose the number of equal parts and that you shaded, so I haven't completed this one, but hopefully you'll have managed that okay. And then the final problem solving one. And then if you could set your timer for 5 minutes and pause the video and do today's Fluent in 5. And here are the answers to today's Fluent in 5. So today we're going to look at comparing fractions, which is more, which is less, which is bigger, which is smaller. So this one I've started off with, Mrs. Downer has made 3 cakes. They are all the same size, and it's really important that we remember in this that the whole cakes are all the same size. She cuts each cake into 8 equal parts. So if the cakes are the same size, then each of the 8 equal parts will be the same size. So Jack eats 3/8 of a cake, Daisy eats 5/8 of a cake, and Millie eats 8/8 of a cake. Millie must have been pretty peckish. I've also put it into a model here. So this means the same as this, it's just represented differently. And I want you to tell me who eats the most cake and who eats the least cake. So hopefully by looking at the models and the diagrams themselves, you can see that Millie has eaten all of the cake. She's eaten the whole cake, so she's eaten the most. Jack has eaten the least. And what do you notice about the numerators in the fractions of the cakes that they've eaten? Millie has eaten 8 pieces out of 8, 8 parts out of 8. Jack has eaten 3 parts out of 8. So 3 is obviously smaller than 8. And that tells us that Jack has eaten least, Millie has eaten most. And obviously 5 is in between those two, so Daisy is in the middle. So if we are looking at fractions where we have the same denominator, so the same number of equal parts, and the cakes or whatever the problem is suggesting are the same size, we look at the numerator to tell us which is the most or which is the least. That's just the answers, we don't need that one. So here we have Lily bakes 2 chicken pies, both the same size. And again, that's really important. I haven't drawn the pies this time, I've just drawn a model. She cuts each pie into 9 equal slices. So that tells us that the slices in Joseph's pie are the same size as the slices in George's pie, each slice. But Joseph eats 5/9 of the pie and George eats 3/9 of the pie. So have a think about it, who eats more? Well, we know that we've got the same denominators, the pies are the same size, so we look at the numerator to tell us which is more. And I know, and I'm sure you know, that 5 is more than 3, so Joseph eating 5/9 of the pie eats more than George, who eats 3/9. You can also see that on the model, so not only do we have the numbers, but you can see on the model that Joseph has eaten more than George. So if we wanted to put fractions in order, we would use the same principle that we've just looked at when we've been looking at to see who ate more or less. This time we've got 3 fractions, all with the same denominator. So we know that each equal part is the same size. This model shows 1/6, this model shows 3/6, and this one shows 2/6. So I'd like you to begin with the biggest, the greatest, and put them in order. See if you could have a go at that. Now hopefully you'll have recognised, not only from looking at the model here, but from looking at the numerator in each of the fractions, that 3/6 is the biggest, the greatest, then we go to 2/6, and then 1/6. So the greatest, that one's next, and this one is the smallest. Have a go at arranging these fractions in order. So these are 7ths, beginning with the smallest. So just by looking at the models, I can see this one is the smallest, this one is next, and this one is bigger. And I can check looking at the numerators in each of the fractions. 2 is the smallest, then 3, then 5, so 2 sevenths, 3 sevenths, and 5 sevenths. Now, if you were asked to arrange the fractions in order and you didn't have the models, you weren't sure about it, what could you do to help? You could draw models, because it makes it much more clear from looking at how much is coloured on these models, just as a bit of a double check. This one is the smallest, this one is the biggest. So if you ever do have a problem where you've just asked to put these in order without a model and you're struggling, draw a model. This is slightly different. Can you see what I've done here? Lily has baked 2 chicken pies. Both pies are the same size. So these represent the chicken pies, and as you can see, they are both the same size. She cuts one pie into 2 equal slices and the other into 4 equal slices. So the size of each of the pies is exactly the same, but the parts are different. George eats 1/4 of a pie. Joseph eats 1/2 of a pie. So this pie has been split into 2 equal parts. Each part is a half. This pie has been split into 4 equal parts, and each part is 1/4. Again, we can look at the model and straight away we can see that Joseph has eaten more than George. Now, this is where things switch around a little bit when we look at the actual digits within the fraction. When we have the same numerator, which is 1 part, and our denominator, which tells us how many parts, the smaller the denominator, the bigger the part. I'm sure you'll remember how our minds were blown when we did this in year 3 earlier on in the year. And it's really important that when we're looking at fractions that have different denominators and we're ordering and comparing them, that we remember that. So with that in mind, have a look at this problem. Emily eats 1/4 of a chocolate bar. Megan eats 1/3 of a chocolate bar. Both bars are the same size. Now, when we have a word problem like that, our instinct is sometimes just to say, oh, 3 is less than 4. So Megan eats less because she's eaten 1/3. When we put it into a model, we can see 1/3 is actually bigger than 1/4, and what you've got to remember is that that third represents how many parts you're sharing it with. The way I remember something like this is I would say, well, would you rather share a chocolate bar with 3 people or 4 people? Who's going to get more if there are 3 of you or 4 of you? And that's a good way to help you remember that having 1/3 is actually better than having 1/4 if you like chocolate. So in this question, who eats less? We can see that the 1/4 is less than the 1/3, so Emily eats less. So here are just a few more for you to have a go at. I'm not going to go through them with you. I'll just show you the answers in a second, but I'd like you to arrange these fractions beginning with the greatest, with the biggest, and these in order beginning with the smallest. So pause the video and have a go at that. And hopefully you will have come up with this. So today's task, comparing and ordering fractions. We start off with a bit of a word problem. 3 cakes, asking who's eating the most, who's eating the least, and which is bigger, which is smaller. And then I'd like you to put them in order, beginning with the smallest. And then we've got some shapes and fractions for you to compare using the greater than or less than symbols. And then some fractions for you to order, beginning with the smallest on this side, the biggest on this side. Now, you'll need to pay close attention to the denominators. Up to here, they all have the same denominator, so you're going to use the numerator to help you order them. But the last 2 on each side have the same numerator, but the denominators change. So you have to think really carefully. Now again, if you're struggling with that, draw a little model to help you, and we'll give you the answers tomorrow.